learning about the basics of physical computing using a microcontroller and a couple sensors and a little bit of programming on the desktop. And we're going to make a ball move around on the screen by moving our hand like a Wii.
Excellent.
Okay.
Okay, let's get started.
All right, let's get started. So to do this, we're going to need a few parts. We're going to start with a microcontroller. And a microcontroller is just a little tiny computer. This one is an Arduino microcontroller. And what it is it lets us write programs on it, and we can attach sensors to it, or we can attach motors to it, or buzzers, or speakers, or lights, and we can both read physical actions, and we can make things happen like lights or movement and so forth. In this case, what we're going to do is we're going to attach this sensor right here to it. It's called an accelerometer, and it measures tilt. So we'll be able to tilt this back and forth in two directions, and we'll be able to know roughly how far we're tilted. In other words, we're basically building our own Wii controller. So the first thing we need to do is we need to power it up. We'll plug it into the computer. It's going to draw its power from the computer's USB port. And then we're going to open up a programming environment called Arduino, and we're going to write a program for it. This particular piece of code you would get from my website, tygo.net/pcomp, P-C-O-M-P/code. This is a fairly common example, though. You'd see this, a lot of versions of this all over the web if you just search for Arduino plus accelerometer.
Gotcha.
Okay. All right, so let's talk through what's happening. So the first thing that's going on the board here is that the accelerometer has particular pins for output and input. You can see that they're labeled ST, XYZ, ground, and VDD. And ground and VDD are ground and voltage, and that's where it gets its power from. ST is just a self-test pin. If you put voltage on it, forces it to test itself. And X, Y, and Z refer to the three axes. X in this direction, Y in this direction, and Z in this direction. When you tilt it, what happens is the voltage on one of those three pins, X, Y, and Z, will change. And it'll change relative to the amount that you tilt it. So in order to run it, what we need to do is we need to give it power and ground. What we're going to do is we're going to set up two of the pins on the microcontroller here to act as power and ground, and three of them to act as what we call analog inputs. That means they're going to read the voltage, the changing voltage, as an input, and they're going to convert it into a digital number in the computer's memory. So we're going to plug it into the board. And then in our code here, we've got a couple lines at the very top that do just what I described. The first set of lines are these ones that say pin mode. That tells the computer whether the pins that we're using are inputs, that is, if they're measuring voltage coming in from something or other, or outputs, meaning that they're outputting voltage to another device. In our case, pins 14, 18, and 19 are going to be outputs because they're going to be the power and ground and the self-test control. So once we've done that, we're going to set the pins appropriately there. So the self-test wants to be high, so it's turned off. High means that it's putting a high voltage on the pin. Low means that it's putting a low voltage on the pin. In our case, that's 5 volts for high, 0 volts for ground. So that goes high, ground goes low, power goes high, and then finally we're also turning on pin 13, which happens to be connected to a little light-emitting diode or LED on the board. We're using that as a power light, because you can't have an electronic device without a power light. So then what we're going to do is we're going to write our own little protocol to communicate between the computer and the desktop. And it's going to be a very polite protocol. We're going to set it up so that this computer's not going to do anything until this computer says, may I have some data? So it's just going to sit around waiting for data to come in, and then it's going to send one set of data back to the other computer. once it gets something, it reads its readings from the three channels, three sensors, the X, the Y, and Z, and it prints them out and sends them to the desktop computer. So I'm going to run that and show you that now. So I'm going to start up what's called... You can see that basically it's just this back and forth protocol of me saying something and it saying something back. And you can also see that as I tilt the sensor, the numbers change. So for example, if I tilt it way down like this, we should see the y-axis change because we can see that the y-axis is the one that tilts in this direction. So if I tilt like that, we see the second number, which is the y-axis, way down at 511. If I tilt all the way in the other direction, then what we get is 624. So we can see that's a big change between the two. What that number means is kind of irrelevant. It's kind of like asking, you know, does this amp go to 11? Well, why does 11 matter? It's one more than 10. In our case, we're just going to use that range of numbers to move something on the screen. Okay? So, we've got that going in that direction. Let's just see if the other direction is working as well. So if I tilt all the way this way, the first number should change. And there we see it at 495. And if I tilt it the other direction, now we see it at 616. So we can see that both axes are working pretty well. Okay, the next thing we're going to do is we're going to write a program in another programming environment to read the data on the computer and to draw something on the screen. We're going to use a programming environment called processing that is in fact the environment that Arduino was originally based on. And it's a programming environment, again, very simply written so that people who don't have a lot of experience programming can nonetheless get going with it pretty quick. And this program is going to take those X and Y readings and it's going to translate them into the movement of a ball on screen. Without explaining all of the code, I'll tell you that there are three main parts to it. There's what we call the setup, and that's this section here. And in the setup, we basically set the size of the screen, and we open our communications port, and we set a few parameters here and there. Then there's what's called the draw, and that's the thing that happens over and over again, and it just draws the ball on the screen, and it draws its position based on some variables that we're going to get from the microcontroller. And finally, there's what's called the serial event, and the serial event is the part that reads the data in from the microcontroller and prints it out so that we can see the whole thing. The whole thing is running. It looks kind of like this. We can see there's our ball, and it's a little jumpy because our sensor is not exactly well tuned. And we can see that as we move the sensor from left to right, we can see it going up, down. As we move it up, down, we can see it going left, right. Why? Because we got our sensors backwards. But we can see that as I tilt like this, it moves left, right. Of course, we could also just do this. Ooh. Wow. Ooh, wow. And then up, down, we move the ball that way. Now, there's still work to be done. We'd still need to, like I said, smooth that out so that the ball wasn't quite so jumpy. And we'd probably like to make it so that the ball could stay in one place when we weren't moving. But that's the basic idea behind pretty much all physical interaction. We take data in using sensors that convert mechanical energy to electrical energy. We read that electrical energy on a microcontroller, we convert it into digital data, and we send that digital data over to a computer where we use it to do something like make an animation happen. That's the whole story.
Now, if you wanted to kind of hack into a Wii console, how would you do that with this? Is that possible?
Well, that's a good question. So if we wanted to actually make this into a Wii controller itself, right now, we've written a pretty simple protocol, a pretty simple language for this to communicate with the desktop computer. And we have the advantage of being able to control both sides of the conversation. We both wrote the program here, and we wrote the program here. With the Wii controller, we wouldn't get that. So at the Wii console, we'd have to know the protocol that it's listening for, and we'd have to write our program on this controller to speak that protocol. I think with the Wii, they're actually using a protocol called HID, the Human Interface Device Protocol, which is part of USB. So we would just need to learn the various structures to write on this program to do that. And then this would show up to the Wii as if it were a controller and do exactly the same things that the controller does now.
And you would set up that interface through the code that you were using earlier?
Yes, I would set that code, I would write that code in the Arduino environment here. I'd basically look online to learn the protocol, and then I'd write a version of it there. I'd probably also have to attach one more thing. Right now we got a wire connecting the two computers. It's a whole lot easier when this can be wireless, and in fact that's the whole point. With the Wii, it's just, you throw the whole thing around, right? So what we'd want to attach is we'd want to attach a radio, in this case what we call a Bluetooth radio, that would pair with the radio in the desktop computer, and then the two devices would send data back and forth over that radio